Research and innovation in futuris.
Definitely the glaciers in Greenland are retreating.
We see the big ice streams are increasing their velocity and thereby producing more icebergs out into the ocean.
Global warming is often blamed as the cause of Greenland's unstoppable melting. But lately, researchers have identified another unexpected suspect.
The clues are hidden here underneath the ice.
Summertime is the peak season for glaciologists in West Greenland. Danish glaciologist Bo Vinther drives to Russell Glacier, a huge ice mass that is quietly melting under rising temperatures. But scientists suspect another mysterious factor also plays a role in this rapid, constant melting.
We are right here at the ice margin, so this is where the Greenland ice sheet terminates here, so the very edge of the big Greenland ice sheet that actually stretches 1,000 kilometers towards eastern Greenland this way here. What we observe is that when we have water underneath the ice sheet, then the ice is flowing much, much faster than if you have the ice frozen to the bedrock underneath. So in that sense, it's really important to investigate these physical processes going on at the very bed, and so we are better able to model them and also in that sense predict the ice flow in the future.
Scientists at a European Union research project are using the heavy gear to understand the impact of those invisible water flows inside Greenland's ice sheet. For that, they regularly fly to a scientific camp unlike any other. The camp was established in 2007 to allow deep drilling in the ice sheet. Scientists here are aiming to unveil the mysteries lying under 2.5 kilometres of ice. The location of the camp was carefully chosen.
We need a site where we knew something about how much snow is falling each year. We don't want too much snow because then the ice is not old enough, and we don't want too little snow because then the resolution of each year is too little. So we pick this spot by combining those two criteria.
The camp's scientific jewel lies deep in a snow trench. Researchers drill here to reach the deepest ice that lies just above the bedrock. Geothermal energy may heat this deep ice to melting point, creating flows of water. Recovering that deep ice is crucial to understand what is really happening far beneath.
We were so far been able to produce in the order of, let's say, at least 20 meters per day in the average. And this is also a production which fits very well our capability of analyzing the ice, because the ice has to be cut and there's various measurements which have to be taken care of.
Something's kind of happening here actually right now. We're actually doing a run as we speak to you, and something is changing here, which looks good. We're not sure when we're going to hit what we're supposed to hit down there. So we've had a few false alarms, but we've also, of course, pulled up a lot of mud and ice and dirt and sand and things.
Scientists date deep ice with a technique called luminescence. Samples have to be extracted in almost complete darkness. Some samples can date back 400,000 years.
I'm very happy that this has worked out that well, as it seems we have lots of material that we can work with, both for DNA analysis and for time dating with luminescence. It's always good to work with the same sample material and to have both results, and this is the first time it worked. It's good to have material with less grains for time dating, but now we've obtained silted ice as well, with a lot smaller grain size. It's very good to have that for comparison.
Each sample will also indeed be analysed to extract DNA traces that will help to unveil biological secrets from times when Greenland was ice-free and water was flowing on its surface.
With the genetic tools, we can get access to the archive of the past environments. And it's not for sure that we have DNA preserved, but if we have, it will be very valuable for describing how the environment looked like, what kind of organisms lived here.
Researchers are also using sophisticated ice-penetrating radars to map the ice's different layers. And radar has confirmed the existence of water flows at different parts of the bedrock.
Water acts like a mirror, so it sends up almost the whole radar signal again. Whereas if you just have normal dry sediments, then it will absorb something and you don't get a stronger signal back. So for example, this area here, if this is melting, then the layers will be dragged down by the melt. And then all of a sudden on the other side, there's a jump and it's back up here. And this probably means that this is dry. And this is a very good indicator for what the bed of the ice is like.
Scientists have established that water under the ice can lubricate the ice sheet and speed up its melting. But that same water can hold other secrets. Here, at the University of Copenhagen, researchers work inside fridges at minus 26 degrees centigrade to determine if water flows under Greenland's ice sheet, which can be important to potentially form invisible, forgotten lakes.
I think actually we have found a small lake under the Greenland ice sheet now, but they are much more rare than in Antarctica, and that's actually very interesting in itself. I think there's two reasons why we don't find a lot of lakes under the Greenland ice sheet. One is that in the central basin of the Greenland ice sheet we have sediments at the base, so we do have water, but it's flowing in the sediment, so in that way we don't see it as lakes at the bottom. And secondly, because the Greenland ice sheet is smaller than Antarctica, so it's more dynamic, we have more snowfall, the slopes are steeper, so in that way that the pressure on the bottom is stronger and it's more difficult to form the lakes at the bed.
And lakes, researchers say, could even sustain particular forms of life under 2,500 meters of ice.
When we have a lake under the ice, we have a reservoir of melted water that has been formed far, far back in time. And for the Greenland ice sheets, it's several million years back in time. It's always very fascinating if there's, its own life form that has been forming, if the bacterial life has further developed, being very isolated from the rest of the climate system. So you find life forms you don't find elsewhere. So of course this fascination is one of the reasons for searching for water under the ice, and when it's found, perhaps try to start programs where you drill into the lakes.
And researchers conclude they are far from having drilled out all Greenland's icy secrets.